Good morning, guys. Good to see everyone online, or I guess good for you to hear me anyway. I hope you're tuning in. Hope you're ready to tackle the next set of Cornell notes from slides 25 through 47. Sorry, my internet's loading a little slowly, but you're going to see the lungs here in just a second. There they are. So when we move, we moved from the trachea that we were talking about yesterday or the other day, and it splits into these two main bronchi. Those actually, you can see here, they actually go into the lung tissue, carrying that air that you've just inhaled. Okay, and you can see they are a nice pink, healthy color. You can see we have the apex here, we have the base of those here, and you can see there is a space right here, and I think you know what should be there. All right, the heart is what goes there when it's drawn in. So here you see you have your left lobe of your lung, your left two lobes rather. You have your right lung with the three lobes. And of course, this space here where the heart goes is the reason that your lungs are designed with only the two lobes on the left side. You see down here in the inferior margin of excuse me, the cavity, you see the diaphragm here. All right, that's where the lungs are resting on. And you can see here the pleural fluid we've been talking about that's found between those two serous membranes. All right, the visceral pleura and the parietal pleura. All right. So here's another diagram that you guys can just take a look at, get oriented to the cavity. Remember, this is the thoracic cavity. I hope you don't ever forget that. Okay, so let's talk a little more about these serous membranes. Okay, so here we see the lung itself. We see that what's lining that lung is that visceral pleura. Okay, they also call it the pulmonary pleura, and that's covering or hugging that lung surface. Over here against the wall of the thoracic cavity, we see the parietal pleura. Excuse me. So don't forget those two, the visceral hugging the organ, the parietal lining the cavity that the organ is found in. Okay. Remember, the pleural fluid found here between those two membranes allows this lung to expand, to contract as you go through that process of respiration. The interesting thing here is that you see the last bullet point there says these two pleural layers resist being pulled apart. And we're going to talk about that negative pressure that these basically kind of suck to each other so that normal lung function can happen. And we'll talk more about that here in just a little bit. Okay, another view of that diagram. We're going to see that a lot. As we keep on going deeper into the lung tissue, these larger bronchi branch into the bronchioles. We have basically the primary bronchi branching into secondary, tertiary, etc. And then when they get really tiny, they're called bronchioles, okay? And they end in what's called the terminal bronchioles. And we know terminal means endpoint. So the interesting thing about these is that all of the smaller bronchi have the reinforcing cartilage because, again, we want to keep that airway open, okay? So hopefully that makes sense. Okay, here is the end point of that part of the bronchioles that you see. This is actually called the respiratory zone. We'll talk about that more in just a little bit, but we have the end point of those terminating in the terminal bronchioles, and those are going to branch into what are called respiratory bronchioles. And this is what's known as the respiratory zone. Okay, so once this terminal bronchiole begins to branch into the respiratory zone, it's called that because this is where respiration technically happens. Remember, respiration being the exchange of these gases, O2 with CO2. And so we have these specific structures involved in the respiratory zone that are involved in gas exchange. Okay, here we see this, what looks like a cluster of grapes known as the alveoli. One is called an alveolus. The group of them together are called alveoli. This is so cool. Take a look at these capillaries surrounding the alveoli because, of course, we know that the gas exchange is happening in the blood. So we've got to hug these alveolar surfaces with these capillary networks so that we can exchange these gases. So that is your respiratory zone right there. Here's what it looks like actually through a microscope.